You're welcome back. This is Mr. Hassan's Maths channel, and I'm answering question number 1 from the P3, Pure Mathematics P3 International A-Level Edexcel paper. And this question is from the October 2021 session. For some reason, it's not written on the front of the paper anymore. I don't know why. I don't see it anywhere. But anyway, this is the October 2021 paper for P3, Pure Mathematics P3. And I'm going to answer questions one by one, separate videos, in order that I can classify them by topic as well as by paper. So you will find in the description of you'll find on the end of the video a link to the playlist somewhere appearing in this area, and you'll also find in the description of the video a link to the playlist of this paper, and in the playlist description you will find a link to the PDF version of this paper. Okay, so this question here is all about functions, and it says the function f is defined by f of x equals 5x over x squared plus 7x plus 12 plus 5x over x plus 4, where x is greater than 0. Show that f of x equals 5x over x plus 3. Okay, so now here we have to basically simplify this and show that it becomes 5x plus 3. So we need to add these two fractions together. Now, when we are adding together algebraic fractions, then the same rules apply as adding normal fractions. We have to add them together when the denominators are the same. So we have to find the lowest common multiple of the denominators, and that's the easiest way to then add them together. Now, one of them is in this quadratic form, which it seems can be factorized. In fact, one of the factors will be the same as x plus 4 here. You can see this is going to become x plus 3 times x plus 4. And that's going to help us greatly to simplify this. So what we can do is you can say f of x is equal to, so I'm going to write this in its factorized form, f5x over x plus 4 times x plus 3. That's x squared plus 7x plus 12 factorized, plus 5x over x plus 4. Now what I need to do is I need to combine these together. I have to make the denominators the same. Now, the best way to do this is to find the lowest common multiple of the denominators. And that is basically x plus 4 times x plus 3. All right, now I saw some students, when I set this question for my students, take the LCM or take a multiple of x plus 4 squared times x plus 3, which is a multiple, but it's not the lowest multiple. This is the lowest multiple, the lowest common multiple of these two terms. All right, so you need to try to find the lowest common multiple to give yourself a question, or to make life easier for yourself, let's say. Okay, so if you choose x plus 4 squared times x plus 3, then it will work, but then you're going to have a problem when you are trying to simplify it. You're going to have like a big quadratic up here, and then it's going to become way more complicated than it should be. And if you remember, the P3 paper is one where you have to be very efficient with your time. We have 1.5 hours, and there's quite a lot to do. So if you start off by making life more difficult for yourself and doing things which take longer, it's going to unnecessarily waste your time, and you might not have time to complete questions later on. All right, so it's important for you to take that into account. So it's very important that we see that finding the LCM is always the most efficient to do. So if I make both of these with the same denominator of x plus 4 times x plus 3, this one doesn't have to be touched. This one I have to multiply the denominator by x plus 3, therefore the numerator by x plus 3, such that the denominators become the same, and then I can add the numerators together as one numerator. So 5x plus 5x times x plus 3 over one common denominator now, which is x plus 4 times x plus 3. Now we can simplify this numerator. We can expand the bracket here, so you have 5x plus 5x times x, which is 5x squared, 5x times 3x, which is 15x, over x plus 4 times x plus 3. And then we can, x plus 3, then we can simplify the numerator slightly by combining the x terms. That's going to give me 5x plus 15x, so you have 5x squared plus 20x over x plus 4 times x plus 3. Now we have to show that f of x becomes this, and we can see that the numerator can be factorized. 5x is common, so that's going to give you 5x as your factor. Then you have x plus 4, And as we see, we have x plus 4 multiplied by x plus 3, and we can see that x plus 4s can cancel out, so you're left with 5x over x plus 3. So therefore we can say the function f of x is equal to 5x over x plus 3. So we've now simplified it and shown what we had to show, and there's our answer for part A. Okay, so that's something important to take into account. As I mentioned, the LCM of the denominators is not x plus 4 squared times x plus 3, it's just x plus 4 times x plus 3, and that will make life a bit easier for you if you stuck to that. Now, one very important part of this question here, which I'm going to note, is the fact that they've mentioned that x is greater than 0. They've restricted the domain of this function, and that will definitely have an effect on other parts of the question, and we have to take note of that. Now, question number 2, or question part B, says find the inverse of fx. And as I just stated, we know that the original function has a domain which is restricted for x values which are greater than 0. Now that is going to have an effect on the inverse function, and many students, they don't take that into account, okay, and they lose marks. All right, so even though the question does not say find the inverse of the function f and state its domain, okay, you must state the domain of the inverse function, okay, because the domain of the original function has been restricted. Okay, so sometimes they do, especially in the past, they would write find the inverse function and state its domain. Okay, but they don't have to say that, and there are marks given for stating the domain, especially when the original function has been restricted in its domain. Okay, so that's something that most students don't take note of, so it's a very important point. So first of all, let's find the inverse function. Now the inverse function is basically the reverse, or the function that undoes the original function, you could say. And to find the inverse function, first of all, we'll call f of x y, because y equals f of x. So y equals 5x over x plus 3. And when you're finding the inverse of a function, you're basically reflecting in the line y equals x. So the x-axis becomes the y-axis, and the y-axis becomes the x-axis. So that y becomes x, and the x becomes y. You can think of it like that. Now, when you want to find the inverse function, okay, we have to basically now make this y the subject. If we make this y the subject, then we will have found the inverse function. So to make y the subject, first let's get rid of the fraction. Let's multiply both sides by y plus 3, so we don't have any fraction left. Okay, now we want to make y the subject, so this y has to be released from this bracket. So you expand the bracket, you have xy plus 3y, plus 3x, not 3y, xy plus 3x equals 5y. And now we want to make y the subject, so the y's must be brought together on one side of the equation. So I'm going to choose this side for the y's. So this is going to be 5y minus xy. This side already has the x's on it, so I'll leave that there. And now we can basically take out this y as a factor, just to have one y term. And now we can divide both sides by 5 minus x. So you have 3x divided by 5 minus x equals y. So therefore the inverse function is equal to 3x over 5 minus x. There's the inverse function. Alternatively, at this stage here, what we could have done, and some people would have done, and it's perfectly fine, is decide that we want to keep the left side for the y. So we would then subtract 5y from both sides, and we would subtract 3x from both sides, and then we would take y as a common factor, and then we would say, okay, y is equal to minus 3x over x minus 5, and both of these are perfectly fine. Okay, so if I write the inverse as negative 3x over x minus 5, or I leave it in this form, both of those are basically the same thing. Okay, it's just that it's like saying minus 2 divided by 3 and 2 divided by minus 3. They're both equal to the same thing, minus 2/3. So they're both the same, basically. Here the top is negative, here the bottom is negative, and they're the same thing. All right, so that's the inverse function. Now, as I mentioned, it's very important for us to realize that when they have restricted the domain, even if the question does not tell us to find the domain of the inverse function, we should do so. Okay, we should do so. Now, the original function had its it was defined by 5x over x plus 3. and they told us that x is greater than 0. That was the domain. Now, one of the best ways to find the domain of a function on the range of a function is to sketch it, okay, to find the domain and range of a function. And I know that the range of this function is the same as the domain of the inverse function. So if I find the range of the original function, that will give me exactly the domain of the inverse. Now, for me to draw this function, I've got to think about this as this is right now an improper fraction. I'm going to think of this as a mixed number. So I'm going to split it up into a whole number part and a proper fraction. Okay, you can do that by long division. You can do that by just rewriting the numerator. I mean, basically what we can see is the asymptotes are going to be x equals minus 3, which won't really count because x is greater than 0. And the other asymptote will be y equals 5. Okay, so let's just make a little... let's just rewrite this so that we can see how it's going to look. So if I rewrite this, this is one way of doing it. I'm going to write this as x plus 3 in the denominator, and I'll write this as x plus 3 in the numerator as well. Now I want to end up with 5x, so I have to multiply this by 5. I'll get 5x, but then I'll have plus 15. I don't want the plus 15, so I'll take away 15, and then I can write this as 5 times x plus 3 over x plus 3 minus 15 over x plus 3. They cancel, you're left with 5 minus 15 over x plus 3. Okay, so you know that this is what the function is, okay? And if we try to draw this, function, it would look something like this. Just make a little sketch so we can see what it looks like. We'll have an asymptote at x equals minus 3, which actually won't count. I'll just draw it for now, just to show. And then y equals 5 will be the other asymptote, the vertical asymptote, so it's going to go something like this. Let me just make it a bit more slightly to scale. So this is x equals negative 3 and y equals 5. X equals negative 3 is one asymptote because that's what causes this to be undefined, and x equals 5 is the other asymptote. All right, so now this is negative. It's like negative 1 over x, because you have negative 15 over x plus 3. So normally a positive 1 over x will go like this, and the negative they'll be in these two. So it's going to go on these two sides. Now this graph, when x equals 0, you have 5 times 0 over 3, which is 0 over 3, which is 0. So it's going to go through the origin, this graph. So it's going to go something like this. Okay, this is how it will look. If you draw it unrestricted, it will look something like this. Okay, it will look something like this if you draw it unrestricted. And then you'll have the part on this side as well, the two asymptotes. Now, this is restricted to x is greater than 0. So basically all of this part won't exist, and all of this part won't exist, and it will start, you can say, with an open circle here. Okay, so let me just make it clearer. You will start here with an open circle because 0 is not included, x is greater than 0. So it's going to look something like this. So the domain of this function, as we can see, is x is greater than 0, but its range is restricted between these two. It will never go below this because its domain is from x equals 0, so this part of it does not exist. And it will never go above here. Okay, it will never go above here because this part of it, again, doesn't exist, because its domain is restricted to x is greater than 0. When x is greater than 0, then it will only exist from 0 up to 5. So we can say that the inverse function, we can say that f of x equals, inverse of f of x, is equal to 3x over 5 minus x. And you can say that its domain is x is between 0 and 5. Its domain is x is between 0 and 5. Okay, and there we have the full proper answer to this question. Okay, so when the domain of the original function is restricted, as it has been in this question, and they ask us to find the inverse, we must state the domain of the inverse function. Okay, and the domain of the inverse function is the same as the range of the original function. This is a sketch of the original function, which is y equals 5x over x plus 3, and we saw how it becomes this, which is easy for us to sketch. This is an asymptote, x equals minus 3 is an asymptote, but we don't have to worry about the x equals minus 3. Just from here, up to 5. It won't ever go above 5 if the only part of it that exists is when x is greater than 0. Okay, so that's very, very important, and that's the answer to part B of this question. Okay, I took a bit of time to explain this because it's something that is important for us to do, but it shouldn't take you long to work it out yourself. If you were doing an exam, you have to get used to this type of thing and how to sketch them. Okay, I could have also found this by doing long division. I could have said, okay, x plus 3 into 5x, x times 5 is 5x, 5 times x is 5x, 5 times 3 is 15, and then you subtract, that gives you negative 15. So we know that when we divide 5x by x plus 3, you end up with 5 as your whole number and minus 15 as your remainder, so minus 15 over x plus 3. So you can do it quite easily by long division as well as rewriting the numerator. Both of those methods are perfectly good to get the function in the form that you can then sketch. When it's written in this form, it's easy to sketch. Okay, so there we have the answer, as I said, to 1 part B. Now we're going to go on to 1 part C. Okay, 1 part C says find in its simplest form f dash of x. So we have to differentiate this function, and to differentiate this function we're going to use what is called the quotient rule. Okay, the quotient rule. Now the quotient rule is a rule where we have to whenever you have a quotient of two different functions, then unrelated, we can use the quotient rule. Okay, so what I'm going to do, I'm going to call one of them, I'll call the numerator, we have to call the numerator always, the numerator is u, and the denominator we're going to call it v. Okay, and then you're going to find the differential of the numerator. So if you differentiate 5x with respect to x, you get 5. If you differentiate x plus 3 with respect to x, you get 1. And for the quotient rule, so dy dx, or we can say f dash of x in this case, as I gave it in terms of f of x, we can say f dash of x. You always start with this top right, times, so it's v times u dash, which is 5 times x plus 3. So I always go diagonally across, starting from the top right, and then it's going to be minus 5x times 1. Now this formula for this is in your formula book, but if you set it out like this, it becomes really easy. For the quotient rule, you multiply them and you subtract those two, and then divide by v squared, which is x plus 3 all squared. Okay, if it was a quotient rule, if it was the product rule where there's a product of 2, then it's just this times this plus that times that. Anyway, so this is the quotient rule, so we're subtracting this times this minus this times that, and then divided by v squared. Now we're going to simplify this. This gives us 5x plus 15 minus 5x over x plus 3 all squared, which gives you 15 over x plus 3 all squared. So we can say that is f dash of x. So this is part 1, finding f dash of x. F dash of x, the differential, is 15 over x plus 3 all squared. Okay, then it says, hence state whether f of f is an increasing or a decreasing function, giving a reason for your answer. Okay, so what we can say here is that the differential of f of x equals 15 over x plus 3 all squared. Now we know that x plus 3 all squared is always going to be greater than 0. Okay, it can't be equal to 0 even, because if it's equal to 0, then this will be undefined, right? So x plus 3 all squared is going to be always greater than 0. Okay, it has to always be greater than 0. And we know that 15 is also greater than 0. So you're going to have a positive divided by a positive. So we can say, therefore, f dash of x is going to be a positive number over a positive number, which is equal to a positive number. Okay, we can say that f dash of x is always greater than 0. It's always going to be greater than 0. Always going to be positive. Okay, so as f of the differential is always greater than 0, then therefore it is an increasing function. Whenever the gradient function is positive, it's going to be an increasing function. Therefore, f of x is an increasing function. Okay, so if its gradient is always positive, it's always going to be going upwards. Okay, that's what that means basically. All right, so when something is an increasing function, that means that f of x is greater than or equal to 0 for all values of x. For x is all real values, okay, it's always going to be greater than or equal to 0, okay. So there we have, we already know that x cannot be -3, so that's what makes this 0, all right. So therefore, that'll never be 0 anyway. Okay, so we could maybe state this: x can't be -3. We know that for sure. So basically, as long as you write this statement down that the gradient function is always positive, therefore it's an increasing function, that's fine. So that's the answer to part 2, question C, part 2. And there we have finished this question number 1 from this paper of P3, October 2021. Other questions from this paper you can find in the playlist that should appear somewhere over here. Other questions from the topic of functions in general, inverse functions and finding the range of functions and such questions like that, adding and subtracting, algebraic fractions. Okay, you'll find them in this. So basically, I'll make 3 playlists. One of the playlists will be about adding and subtracting algebraic fractions, which is from chapter 1 of P3. Another playlist will be over here, which will include the questions to do with finding the range of functions, finding the inverse function, and another playlist here will be for differentiation and the product and quotient rule. So I'll have 3 different playlists to include the topics that are in this paper, and you want to see other questions about those particular topics, you can click on the relevant playlist at the end of this video. Thank you for watching, and see you soon.